Welcome to Max with RP. In the earlier videos, we have been solving problems, word problems using maxima and minima. We will continue with the same. We will do more problems today. Look at this given problem. An open box with a square base is made out of a cardboard of area C square. And you have to show that the maximum volume of the box is C cube by 6 root 3 cubic units. So an open box is made with a square base, is made out of a cardboard. Okay, the same cardboard is folded. It has got a square base. So let X be the side of the square base. So what will be the area of the box? Area of the base is x square plus, let h be the height, y be the height of the box. Let y be the height of the box. It has got 4 sides, so it will be 4xy. Each side will be a rectangle whose area is xy. There are 4 sides, so x square plus 4xy. Open box, so there is no top. This is equal to c square, which is given. Because this box is made out of a cardboard whose area is c square square units. Now what is it that you need to maximize? To maximize, we want to find the dimensions of that box which will have maximum volume. So to maximize the volume, now volume is equal to what? Base area into height. Volume will be x square y. Now both x and y are variables. C square is a constant because it's the area of the cardboard which you are using to make the box. Now this is a function of two variables, so we will convert it into a function of a single variable using this. What is it you have to maximize? Volume. Volume is a function of x and y. Okay, from here you know that 4xy is equal to c square minus x square, or y equal to c square minus x square by 4x. So volume will be x square into c square minus x square by 4x. I substituted for the height of the box, y in terms of x. This will be c square by 4. I am just simplifying the volume. 1x will get cancelled, giving me x, minus x power 4 by 4x, so which will give me x cube by 4. This is c square into x square by 4x. 1x gets cancelled, so c square x by 4. This is x power 4 by 4x. 1x gets cancelled, giving you x cube by 4. We can cancel x because x is the side of the base. This is dv. So now what is dv by dx? dv by dx will be c square by 4. The derivative of ax is a, so c square by 4 minus 3x square by 4. So to find the critical point, we have to equate dv by dx equal to 0. Therefore, c square by 4 is equal to 3x square by 4. So x square equal to c square by 3, or x is equal to c by root 3. So we are saying that the volume is going to be maximum at x equal to c by root 3, because c by root 3, if it is maximum, then it has to be at x equal to c by root 3, because c by root 3 is the critical point. How do we verify? Let us find d square v by dx square. D square v by dx square means I have to differentiate this. C square by 4, when I differentiate, I'll get 0. This will be minus 6x by 4, which is minus 3 by 2 into c by root 3, which is less than 0. So v is maximum at x equal to c by root 3. Okay, now what is the maximum volume? Because the question is, we need also to find the, show that the maximum volume is this. So maximum volume is, what is maximum volume? What is the formula? This is, volume is x square into y, right? So what is x square? C square by 3. So what will be y? Y, you know, is what? From your c square minus x square by 4x. So this is y, c square minus x square, which is c square minus x square is c square by 3 by 4 into c by root 3. This is 2c square by 3 into root 3 by 4c. 6 root 3. So 1c gets cancelled. So root 3c by 6. So c square into root 3c by 6, which is c cube by 6 root 3 units. Being volume, it is cubic units. This is what we wanted to prove, c cube by 6 root 3 cubic units. So the base is an area. Your cardboard, you are taking a piece of cardboard. The area of the cardboard is c square. You are folding it along the four sides to make a box, open box. Base is a square, so x square. The side each is a rectangle whose area is xy. There are four such sides. So x square plus 4xy is c square. We have to find the maximum volume. Volume is base area into height, x square into height. It's a function of x and y. So from here, write down what is y. 4xy equal to c square minus x square. So y is c square minus x square by 4x. Substitute back the for y in the volume. Then this is the expression we get. To find the critical point, differentiate. You get, when you differentiate this, c square by 4 minus 3x square by 4. When dv by dx is 0, when x is equal to c by root 3. So you have found the critical point. Now verify whether it is at x, whether you really have maximum volume by looking at the sign of d square by b dx square. You get negative value. Therefore, at x equal to c by root 3, we have maximum, and the maximum volume is given by what? X square y. That is x square into, I have substituted for y, simplified y here and substituted. This is your y value and I have substituted. So we have maximum volume of the box is c cube by 6 root 3 cubic units. Next problem, show that the surface area of a closed cuboid, that means top is also there, with the square base and given volume is minimum when it is a cube. Okay. So what is it? What is given? Surface area of a closed cuboid with a square base. So x square plus x square will be 2x square. Surface area will be 2x square. Top is a, bottom is a square base. Top is also a square. So 2x square. And it has got four sides. Let y be the height. So s will be 2x square plus 4xy. X is the side of the square. Y is the height of the box. 2x square because it is closed. Okay. Now what is it you have to minimize? To minimize surface area. Now what is given? Given volume. So volume is a constant. Volume is a constant. Because it says given volume. So volume is a constant. So what is V? V equal to x square y. V being a constant. So from implies y is equal to V by x square. Now this is what you need to minimize surface area. So here x and y are variables. So you have to express one in terms of the other. Easy to write y. So 2x square plus 4x into v by x square. This is 2x square plus 4v by x. Because one x gets cancelled. Now I have to find ds. To find the critical point, I have to find ds by dx. Because we have expressed this as a function of a single variable, namely x. So ds by dx will be 4x minus 4v by x square. Derivative of 1 by x is what? X power minus 1. So minus 1 by x to the power minus 2. So minus 1 by x square. ds by dx equal to 0. Therefore, to find critical point is obtained at 4x equal to 4v by x square. V equal to x cube. So, when x is equal to v power 1 by 3, we have the critical point. Okay, now if the volume is x cube, what is it? It is a cube. Right? Now, how do you check whether the volume is minimum? You have to look at d square s by dx square. D square s by dx square will be differentiate ds by dx. Differentiating, I will get 4 minus 4v. I have 1 by x square, so x power minus 2. So I will get minus 2 by x cube. So plus 2 by x cube. This is 4 plus 4v into 2 by x cube is v. So 4 plus 8, which is 12, which is greater than 0. So S is minimum at x equal to v power 1 by 3. Since v equal to x cube, the cuboid is actually a cube when the volume is maximum. So we found, I wrote the expression for S, we wrote the expression for v. Since v is a constant, I can write y in terms of the x, substituted back in s for y. You get 2x square plus 4v by x. Now differentiating ds by dx, you get 4x minus 4v by x square. It's equated to 0 to find the critical point. We get v equal to x cube, or x is v power 1 by 3. So x equal to v power 1 by 3 is the critical point. So that is the point where, if it is if v is minimum, it has to happen. How do we confirm that? Look at the sign of d square s by dx square. We get 12, which is greater than 0. V is x cube. Okay, we have got v equal to x cube. That means what? The cuboid is a cube. Let's go to the next problem. An open tank is to be constructed with a square base and vertical sides. I am combining sums of similar nature. Is to be constructed with a square base and vertical sides so as to contain a given quantity of water. So volume is a constant. Show that the expenses of lining the with lead will be least if the depth is half the width. That means you have to will be the least. So you have to minimize surface area. So volume is a constant. So x square y is a constant. Let me take it as k. So x is the side of the tank, side of the base. Y is the height of the tank. So since V is a constant, I have taken it as k. You get y equal to k by x square. So surface area will be, what is the surface area? It is an open tank. So bottom is x square, sides are rectangular, and each one is a rectangle with area xy. So there are 4 sides, so 4xy. Now y equal to k by x square, because x square y equal to k is a constant. So this is x square plus 4x into k by x square. This is x square plus 4k by x. Now ds by dx will give you 2x minus 4k by x square. Derivative of 1 by x is minus 1 by x square. To find the critical point, equate ds by dx to 0. So you get 2x equal to 4k by x square. Therefore, you get k equal to x cube. Now, what is it that you need to prove? If depth is made half the width. So, the relationship between the height and the depth is y, half the width. Width is nothing but x. So, y is equal to, this is k equal to x cube. Okay. Now, what will be y? Y will be k by x square. So, x cube by x, which is x. So, y equal to k by x square. Okay. And from here, what did we get? X cube is equal to 2k. Sorry. X cube equal to 2k. X cube equal to 2k. So, x is equal to 2k to the power 1 by 3, or k equal to x cube by 2. Now y is what? Y equal to k by x square. Right? K is x cube by 2x square. So x square gets cancelled. So you get y equal to x by 2. Now, when y equal to x by 2, do we really have minimum surface area? How do we check? I have to use the second derivative. So I have to find d square s by dx square will be equal to, this is my ds by dx. If I differentiate this, what will I get? 2 minus 4k. 1 by x square is x power minus 2. So minus 2 by x cube. So this is 2 plus 8k by x cube. Okay. Now what is x cube? X cube is 2k. X cube is 2k. So 2 plus 8k by 2k, which will give you, this is 4k. 4 plus 2, 6. So it is positive, which means s is least when y equal to x by 2. So we have an open tank, okay, with a given quantity of water. So volume is a constant. What is volume? X square y, where x is the side of the base, which is a square. Y is the height. So x square y equal to k is a constant. Okay, so from this y equal to k by x square. Now what is it that you have to minimize? The lining with lead, which is the surface area. So S is equal to x square, open at the top, so it is x square plus 4x. For y I have substituted from here k by x square. I get x square plus 4k by x. Now differentiate this with respect to x. You get 2x minus 4x by x square. Equate it to 0 to find the critical point. You get 2k equal to x cube or k equal to x cube by 2. Right? So this is the critical point. X cube equal to 2k or x equal to 2k to the power 1 by 3 is the critical point. Is it really the critical point? How will you check? With the second derivative. Second derivative is 2 minus 4k into 1. I have to differentiate minus 1 by x square. The derivative is minus 2 by x cube. So both are positive. You can see it's greater than 0. Therefore, it is the surface area is the least. And what is the relation between depth and width? Because yes, we have to prove that the surface area is least when depth is made half the width. So we have to find the relationship between x and y. X, we have already found the relationship. What k is x cube by 2 or x cube is 2k. This is what we have. So from this, what is y? Y is k by x square. So k is what? X cube by 2. So x cube by 2x square, which is x by 2. So y is equal to x by 2. So the surface area is least when y equal to x by 2. So today we discussed about 3 word problems. Please practice them until the next class, when we will discuss more and more problems, because it's such an important topic. Very often questions are asked in maxima and minima, word problems, and therefore we will solve plenty of problems, so that at the end of if you watch the entire set of videos, you should be able to solve any word problem in maxima minima. So until we meet next time, it's goodbye. I hope you're enjoying the sessions Max with RP.